Today we will discuss about the anomalous properties of lithium. By the word anomalous, we mean to say that it is the abnormal behavior of lithium. So, why does lithium behave abnormally as compared to the other elements of the alkali elements? Okay, so here you can see that the anomalous behavior of lithium is due to the exceptionally small size of its atom and ion. Because if you compare down the group, what happens, the lithium is exceptionally very small in size as compared to the other elements in the group. So it behaves as such, like it is very different from the other elements of the group. And also there is high polarizing power, means it is very electropositive as compared to the other elements, and hence it has high polarizing power. We mean to say that the lithium is very different from the other elements, and these are the reasons. Here also one question can be formed is that lithium shows diagonal relationship or behavior with which element. Then you have to say that lithium shows diagonal relationship to magnesium, which has been discussed subsequently. So this is being discussed in the later part of the chapter. For just now we can say that magnesium, which is present in the alkaline earth element groups, so it is like the lithium is little bit one period above than magnesium. So there is a relationship between lithium and magnesium because they show similar properties, and also it is like they behave abnormally. Now the points of difference, we have understood that there is difference in lithium and with the other elements of the alkali elements. Now what are these differences? We're not going to study all of them, but we will just study a little bit of it so that you can write it in the exam efficiently. So the first is that lithium is much harder, so every point is being compared with the other elements. Okay, so lithium is much harder than the other elements. Its melting point and boiling point are higher than the other alkali metals. Because of the such behavior, lithium shows differences. And that is the first difference is that it is much harder. It is harder if you compare all the elements. Lithium is the hardest among all. Next is that lithium is least reactive but the strongest reducing agents among all the alkali elements or metals. On combustion in air, it forms mainly monoxide Li2O and the nitride Li3N, unlike other alkali metals. So lithium is very least reactive and lithium is much harder. So these 2 points you have to remember. Then another point you can remember is lithium nitrate when heated gives lithium oxide, whereas other alkali metal nitrates decompose to give the corresponding nitrate. So when we heat lithium nitrate, we will get lithium oxide, but if we heat other nitrate, we will get the nitrate. For example, it's given here. This is lithium nitrate. When lithium nitrate is heated, you will get lithium oxide, that is Li2O plus 4NO2 plus O2. But if we heat sodium nitrate, what happens? You will get sodium nitrite. Okay, this is NO3 nitrate and this is NO2 nitride plus O2. There is no such formation of NO2. Next, LiF and Li2O are comparatively, lithium fluoride and lithium oxide are comparatively much less soluble in water than the corresponding compounds in other alkali metals. So if you compare lithium fluoride and lithium oxide with other fluorides and oxides, what happens? They are much less soluble in water. But if you if you try to dissolve the fluorides and oxides of other elements in the group, what happens? They dissolve easily. When we are discussing the previous point, we came across one important thing, that is points of similarities between lithium and magnesium. So it is not just one similarity, but there can be many similarities between magnesium and lithium, right? So here you will get many points, as you know, but we are going to discuss only 2 important points that you can write in the examination. The first point is that lithium and magnesium react slowly with water. Okay, they both will react very slowly with water, almost negligible, but other elements in both the groups like alkali metals and alkaline earth metals, both the groups react very fast with water, but except lithium and magnesium. So this thing you can mention. Also you can say that their oxides and hydroxides are much less soluble, and their hydroxides decompose on heating. Decomposition means breaking down. Okay, so breaking down takes place. Their oxides and hydroxides are very less soluble, but up to here if you write, that is also very well. So lithium and magnesium react slowly with water. That's all you can write in the examination, because maximum 2 marks will come for it, or 3 marks. So you can make up the points by yourself if you understand the thing once. Okay, next is that the oxides Li2O and MgO do not combine with excess oxygen to give any superoxide. Okay, next is that the carbonates of lithium and magnesium decompose easily on heating. Another one you can write, both lithium chloride and magnesium chloride are soluble in ethanol. So we have talked about 4 points here, but you can choose to write this point. Okay, this point you can write, this point up to here, up to heating you can write, and here up to water. So 3 points you can mention if 3 marks comes in the examination. We are talking about the similarities, not the differences. This thing you have to keep in mind. Okay, so they both are behaving similar in some cases up to most extent. The next part is about the group 2 elements. You know that we are talking about the group 1 and group 2 elements, and together we know these are the S block elements. Okay, so the group 2 elements are also known as the alkaline earth metals, as I have mentioned many times. Now the group 2 elements comprises of what? Beryllium, magnesium, calcium, strontium, barium and radium. In the previous class I have already mentioned the short forms, okay, abbreviations of these metals. You can go through that class again if you have forgotten. Next you see this, these elements have 2 electrons in the s orbital of the valence shell. So s orbital can have maximum 2 electrons. Okay, so maximum 2 electrons is possible, and so these elements have 2 electrons in the s orbital. That is why s block elements have only 2 groups, that is group 1 and group 2. It will have either 1 or it will have maximum 2. Okay, if there are more electrons, then it will go to another orbital. For example, beryllium, you know it's 4, right? 4 atomic number is there. So how you will start? 1s2, 2s2. Clear? After that, no more any electrons is there. But for magnesium, you see here, you know that for magnesium it's 12, right? So it is 1s2, 2s2. After 2s, some more electrons are left, right? So we will use 2p. P can have maximum 6 electrons. Is there any electrons left? Yes, we have 2 electrons left again. So it will come to 3s2. Clear? So if you compare this, what happens? You see it is 2s2, 3s2, 4s2, 5s2. It means if you go down the group in the periodic table, what happens? The shells are increasing. If it is 2s, then again 3s, new shells are increasing. That is why I have already said that when you go down the group, the size of the metals or size of the elements always go on increasing. Therefore the radius is also increasing. Clear? And ionization enthalpy is also decreasing, because if you are moving the means the length you see here, the radius. Okay, if you compare, what happens, if from the nucleus, this 2s electron is a little bit nearer as compared to this, and this 5s electrons are like the last orbit is very much farther from the nucleus. So these s electrons can be removed easily, and it will not require much energy. So here ionization enthalpy also decreases, because with less energy only you can remove the electrons. But if you want to remove these electrons from here, what happens? You will require more energy. You need to apply more heat. Clear? Why? Because it is very near to the nucleus. if you draw circular, what happens from the center? The 2s orbitals are nearer, so you will require more energy in order to pull out that electron, because this positive is attracting the negative charged electrons, right? So that energy is higher and you will require more energy to remove that electron, and hence the enthalpy, the ionization enthalpy also is higher.